is another example for goodness of fit hypothesis test. In this example, notice that we have unequal proportion. So 30% of the chance student will receive an A, 10% of the chance student will receive a B, 20% chance for C, and etc. Okay. So in this case, we drew 143 samples, and this is what we observe. And what we expect is to have 30% of the data in the first category. So that would be the sample size times 0.3, which equals 42.9. And then 143 times 0.1, which is 14.3. Now, a very common mistake is to use that 24 and multiply with 0.1, and that would be wrong. I know it's a common mistake because I made that more than one times. So I'll go ahead and finish this calculation. And here I have 14.3, and here I have 42.9. For here, let's pull out the graphing calculator and review the goodness of fit function again. So the first thing I want to do is go into my list. And then since I already have data in L1 and L2, I will go ahead and clear the list. The reason I want to go ahead and clear the list instead of just typing over the list is because if your previous data set has, for example, 7 entries, and now we only have 5, when you get to the end of the entry, you will get into trouble. So that's why it's always a really good practice to go ahead and clear the list before you enter the new list. 14.3, 28.6, 14.3, 42.9. Okay, so let me get out of here and then go to Stat, highlight Test, and I will scroll up to find the bottom of the list. So here is my goodness of fit, and by default that is L1, that is L2, and in this case once again we have 5 categories, so the degree of freedom is 5 minus 1, which is 4. So I could go ahead and carry out my calculation, and that looks like the right answer. Okay, so if you have any question, please do not hesitate to ask me or post on the discussion board.